Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from electromagnetic induction and alternating current chapters. Okay, our first question is two conducting circular loops of radii R1 and R2 are placed in the sample plane with their centers coinciding. If R1 is greater than R2, the mutual inductance between them will be directly proportional to. Okay, now let us see what he gave. He told that he took two circular loops of radii R1 and R2, and he told that R1 is greater than R2. So the radius of this is R1 and the radius of this is R2. Now what did he do? What did he say? He told that their centers are coinciding. Okay, and he asked us to calculate. He asked us to give the information about mutual inductance. The value of mutual inductance is directly proportional to what value? Okay, so let me take this as my primary coil, this as my secondary circular loop. Okay, let I be the current flowing through primary loop and Is be the current flowing through the secondary loop. Now, since IP current is flowing through the primary loop, what will happen? Magnetic field will be generated by the primary coil, and these magnetic lines of force will pass through the secondary coil. That is, there will be some flux linked with the secondary coil phi s. The formula for that phi s is M into current flowing through the primary coil. Okay. Now, this flux phi s is because of this primary coil. Okay, so this phi s can be written as magnetic field at the secondary coil because of primary coil into area of the secondary coil, that is equal to m into ip. So magnetic field because of primary coil, which we can write that this bp as mu naught if it is one turn, no, mu naught n is equal to 1, that is mu naught current flowing through the primary coil ip by 2r. Okay, so mu naught I by 2r. What is r? R is the radius of the primary coil, that is r1, into area of the secondary coil, that is pi r2 square, that is equal to m into ip. Okay, this ip will get cancelled. So we can, and so from this we can write mutual inductance m is proportional to radius of secondary coil r2 square by radius of primary coil r1. Okay, so the answer for this is third option. Now let us move to our next question. An inductor of inductance L and capacitor of capacitance C and a resistor of resistance R are connected in series to an AC source of potential difference V volts as shown in the figure. Potential difference across L, C and R are 40 volt, 10 volt and 40 volt respectively. The amplitude of the current flowing through LCR series circuit is 10 root 2 ampere. The impedance of the circuit is. Okay, now let us see what he give. So this is an inductor of inductance L, this is a capacitor of capacitance C, and this is a resistor of resistance R, and these three are connected in series as shown in the figure. Okay, and this LCR combination, he applied a potential V. Okay, and he gave that the potential drop across inductor is 40 volts, the potential drop across capacitor is 10 volt, and the potential drop across resistor is 40 volt. And he told that a current of amplitude, that is I naught, which is equal to 10 root 2 amperes is flowing through the circuit. Okay, if I naught is 10 root 2, then what will be IRMS? IRMS is equal to I naught by root 2, that is equal to 10 root 2 by root 2. Okay, root 2 will get cancelled. So a current of 10 ampere is flowing through the circuit. 10 ampere current is flowing through the circuit. What did he ask us to calculate? He asked us to calculate the value of impedance. Impedance created by the circuit. Okay, so first let us try to calculate the voltage across this LCR circuit. Okay, so if you observe the phasor diagram of this LCR circuit, the voltage across this LCR combination or the net voltage can be written as V is equal to root over VR square plus VL minus VC whole square or VC minus VL whole square. Okay, so we have the value of VR, we have the value of VR, VL and VC. Okay, if we substitute those, what will get? VR is 40 whole square plus VL minus VC. VL minus VC, that is 40 minus 10, that is 30 whole square. Okay, this can be written as that is equal to 10 root 4 4 16 plus 3 is 9, that is equal to 25, that is 5, that is 50 volts. Okay, so a potential of 50 volts is applied across the combination of this LCR. Okay, now he asked us to calculate the impedance. So this Z can be written as V is equal to IR, Z is equal to V by I. V by I, that is equal to 50 volts by current flowing through the circuit, that is 10 amperes, that is 5 ohm. Okay, so the answer, the impedance for this, the impedance created by this LCR circuit is 5 ohm. Now let us move to our next question. A series LCR circuit containing 5 Henry inductor, 80 microfarad capacitor and 40 ohm resistor is connected to 220 volt variable frequency AC source. The angular frequencies of the source at which power transferred to the circuit is half the power at resonant angular frequency are likely to be. Okay, so now let us see what he gave. He told that this is an LCR circuit whose inductance is 5 Henry, okay, whose capacitance is 80 microfarad and whose resistance is 40 ohm. Okay, this is connected to an AC source of 220 volts. Now what he is asking us to calculate? He is asking us to calculate the angular frequencies, that is omega 1 and omega 2, where the power falls to, the power transfer to circuit is half of the power, that is power falls to P by 2 from P. Okay, that is maximum power at maximum frequency. Okay, now you have to calculate omega 1 and omega 2. So what are omega 1 and omega 2? Omega 1 and omega 2 are the half power frequencies. Okay, what is half power frequency? Now let us see this LCR resonance curve. We know that at a resonant frequency omega naught, the power will be maximum. Okay, so half power frequencies are your omega 1 and omega 2. Okay, omega 1 and omega 2, where the power falls to half of its maximum value. Okay, the power falls to P by 2. Okay, so these angular frequencies will call it as half power frequencies. And he asked us to calculate omega 1 and omega 2. And we know that this omega 1 and omega 2 will be equally spaced with respect to omega naught. That is, they will be at a distance of delta omega on either side. Okay, so on either side, there will be a distance of delta omega on either side. Such that omega 1 can be written as omega naught minus delta omega. Similarly, omega 2 can be written as omega naught plus delta omega. Okay, where delta omega is R by 2L. Okay, now first let us calculate R by 2L. This value is R. R is 40 by 2L. 2 into 5, that is equal to, 2 into 5, that is equal to 40 by 10, that is equal to 4. That is, with respect to resonant frequency, these half power frequencies will be at 4 unit distance on either side. Okay, now let us calculate omega naught. Okay, so resonant frequency omega naught can be written as omega naught is equal to 1 by root LC, that is equal to 1 divided by L, that is root over L. L is what is 5 into C. C can be written as 80 into 10 power minus 6. Okay, that is equal to 1 by 400 root over 400 into 10 power minus 6, that is 4 into 10 power minus 4. If you solve, what will get? You'll get the value of resonant frequency as 50 radian per second. Okay. So now the conclusion is our the resonant frequency of this LCR circuit is 50 radian per second, and our half power frequencies are at a distance of 4 units on either side. Okay, so 4 units towards left will be 46 radian per second, and 4 units towards left will be 54 radian per second. Okay, so the half power frequencies are 46 radian per second and 54 radian per second. Okay, this is one way of solving this sum. The other way is, we know that this difference between omega 2 and omega 1 will be equal to our bandwidth. That is bandwidth. Okay, bandwidth BW is equal to omega 2 minus omega 1. That is equal to 2 delta omega. Okay, that is equal to 2 into delta omega is, what did we get? We got delta omega as 4. That is 2 into 4. That is equal to 8 radian per second. Okay, so the bandwidth is 8 radian per second. Now if you observe this option, the bandwidth is 25 radian per second, so this is wrong. Okay, if you go for this, the bandwidth is 8 radian per second. Okay, 8 radian per second, so this is the answer. For third and fourth, the bandwidth will not be equal to 8 radian per second. Okay, so the answer is 46 radian per second and 54 radian per second. A capacitor of capacitance C is connected across an AC source of voltage V, given by V is equal to V0 sin omega t. The displacement current between the plates of a capacitor would then be given by. Okay, so he asked us to calculate the displacement current. He gave a capacitor of capacitance C and it is connected to a voltage source V is equal to V0 sin omega t. Okay, so the displacement current ID can be written as potential across capacitor by its impedance, which is nothing but capacitive reactance. Okay, that is equal to V by XC. Okay, so, and we know that in the case of capacitor, current leads voltage by 90 degrees. So this V can be written as V naught sin omega t plus pi by 2. Okay, by its capacitive reactance. This is V naught. V naught sin omega t plus pi by 2. This is capacitive reactance. Xc is 1 by omega c. 1 by omega c. So this we can write as, if this omega c goes to top, we can write as V naught omega c into sin omega t plus pi by 2. That is cos omega t. Okay. So that is the value of displacement current is ID is equal to V naught omega c sin omega. Sorry, V naught omega. This is this V naught omega c cos omega t. Okay. So this is one way of doing. The other way of doing is, the displacement current ID is equal to, we can write as dq by dt. That is equal to d by dt of T is equal to q by v. Then C is equal, q can be written as CV. Okay, that is equal to C into d by dt of v. V is equal to V naught sin omega t. Okay, this V naught will come outside. V naught into d by dt of sin omega t will be cos omega t into omega t. So omega c, that omega will come outside. That is V naught omega c into cos omega t. Okay, so the answer is V naught omega c into cos omega t. A step down transformer connected to an AC main supply of 220 volts is made to operate at 11 volt 44 watt lamp. Ignoring power losses in the transformer, what is the current in the primary circuit? Okay, now let us see what he gave. This is a transformer, that is step down transformer. He told that this step down transformer is connected to 220 volts, that is along the primary part, and along the secondary part he connected the secondary part to a lamp of power 44 watt. and operating at a voltage of 11 volt. Now what is he asking us to calculate? He is asking us to calculate the current in the primary circuit. That is this IP, that is current in the primary circuit, is what? He is asking us to calculate the current in the primary circuit. And he gave that there are no power losses in the transformer. That means the power in the primary will be equal to the power in the secondary. Okay. So power in the primary can be written as Vp into Ip, and power in the secondary Vs into Is. He gave that value as 44 watt. Okay, that is 44. Okay, and he gave Vp as 220 volts, and he asked us to calculate Ip. So Ip can be written as Ip is equal to 44 by Vp, is equal to 44 by 220. Okay, that is equal to what will happen then? If you solve this, you will get 0.2 ampere. Okay, so the current flowing through the primary circuit will be 0.2 ampere. If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. And to get more updates, kindly subscribe to my channel. Okay, the only thing that I expect from you is a single like, because your single like or comment that you give will encourage me a lot and it will be helpful for me to make better videos. Thank you.